Hello everyone, welcome to lesson S6 on spectroscope and light. First thing we're going to do here is we're going to define spectroscope. It seems appropriate considering the title. And the textbook defines this as a device which produces a focused spectrum. Now this is a very difficult definition. Because the word spectrum is basically a root of spectroscope. And so instead of spectrum, I'm going to write a focused separation of color. Okay, so it's a focused separation of color. Now they come in a wide variety. Couple of examples are here and here, so there's not one, but the most common one that we're going to see in many of these diagrams is just a triangular prism. Now a gas heated at low pressure, so if we've got kind of like this hot gas here, light's going to come through, it's going to go through, and it's going to produce what we call a bright line spectrum. In other words, what's going to happen is you're going to see several bright lines happening over a black background. So it might look something like that. Right, and so you've got these tiny bright lines here. Now a heated solid, so let's make our solid here. If we heat that up, so this is a hot solid, light comes through here, what you wind up with is what we call a continuous spectrum, or a full-on rainbow. Continuous spectrum, full rainbow. Third one is, well, if we take that hot solid and we're going to pass it through a cool gas, and then send that light through a prism, we get, instead of the full rainbow, what we wind up with is what we call a dark line spectrum, which will have a full rainbow with these dark lines kind of in there. So we can take a look at this picture here. Again, we've got a light source. This first one here, this would be what we call a continuous spectrum. Here we've got a dark line spectrum or absorption spectrum. We see we've got the dark lines absorbing a little bit of the light. And here we've got what we call an emission spectrum or a bright line spectrum. Okay, and so these will come through with that. What does that look like video-wise? It will look something like this, where you've got the gas going through a slit and a prism. The slit and prism is your spectroscope here and is creating that bright line pattern. Here, if we take that very hot source, run it through that slit and prism again, you're going to wind up with a full continuous spectrum. And then the third one, you're going to have that hot source again, so continuous spectrum, but running through a cool gas, running through, you're going to see again that full spectrum except with dark lines, like the light has been absorbed from it. Now this can be helpful in us figuring out what specific elements, and we're taking a look at this in terms of specifically a planet. We've got this alien sun producing light, and we can actually, with the light, some of the light passing right through the atmosphere, it would be as if we had light traveling through there, and what gets absorbed here will let us know what's in the atmosphere. The thing is that only specific elements will either absorb or emit very specific wavelengths of light. So in kind of a diagram sort of way, sodium has these two bright bands, hydrogen here, here, and here, where this side is showing what we call the blue side. Notice the blue side is at 400 nanometers in length, right? Compared to the red side, which is 700 nanometers in length. And so what we see here is that the blue side is shorter than the red side, but we've got very specific wavelengths. So sodium is different than hydrogen, which is different than helium. And in fact, all elements have this very specific set of spectral lines. Here we see the full-on ones for sodium and hydrogen, which we had kind of the kitified or diagram version over there. Helium's not on this chart, but we've got calcium and mercury, and each element has its own unique patterns of light. So with that in mind, what is present in this sample? Well, if we notice, we've got this line, and this line, which match up with hydrogen. And we've got those two bright bands in the middle. So this one, and this one match up with this one, and this one. The sodium bands, we've got these two matching up with these two, and therefore we can safely say that this has both hydrogen and sodium in it, because those elements are what we see present in the spectral lines. It's just a matching up of the lines. Doing this with space, though, is complicated a little bit by the Doppler effect, which is a change in the wavelength depending on whether an object is traveling towards or away from an observer. It looks something like this. Right, as an object is moving towards you, okay, we see a shift in it as it passes. Now, as the car is moving towards us, notice that each time it releases a wave, because it's moving towards you, that wave is a little bit closer to the one in front and a little bit further away from the one behind. Now, this is not a squishing, right? The waves keep emitting out as circles. It's just that the next one gets released a little bit closer to this side and a little bit further from the other side. And so what that creates is what we call the Doppler effect, that change in pitch as something goes to and from. And as we pass by, now we see the longer waves here. So as things move towards you, the waves are shorter, and as something moves away from you, the waves are longer. Now, we see the exact same thing happen with objects in space and with light. Now, remember, blue waves are shorter than red waves. And so, red shifting is the apparent movement or the apparent shift in spectral lines to the red side. That red side is longer, and so we conclude that it is moving away. The blue shifting is basically that apparent shift in spectral lines to the blue side. Now that blue side is shorter, and so we conclude that it is moving towards us. And keeping these two clear is important. Red shifting, moving away longer. Blue shifting, shorter, moving towards. So let's take a look at an example here of this star. At the center of the star, we see the lines all lined up like this. But on the right side edge, so on the right edge of that same star, notice that all those lines seem to be a little bit more towards the violet, right? The blue side. We know that this is the blue side because it's shorter, 400 nanometers. And so the right side edge must be moving towards us. On the left side edge, notice the spectral lines are all shifted more towards the red side. And so on the left side, this is moving away from. So drawing this star, let me just get a pen here. So we draw the star on the right edge, right, of that very same star. We know this side is moving towards us. So on the right edge, this is moving towards us. On the left edge of the same star, we move this is away. So this is the left side, and it's moving away from us. So if this is moving towards us, and this is moving away from us, the star must be going this way around in order to see it rotate. And that's red shifting and blue shifting. Now, it should be said that Stephen Hawking, concluding in A Brief History of Time, that one should leave open the question of God. He was pretty much an atheist, but as far as I know, but he left the question a little bit open at least. In December 1924, Edwin Hubble showed that all stars existed beyond the Milky Way. Previously believed our galaxy was alone, and the Milky Way expressed the limits of the universe, and that what we saw, instead of actually being stars, were actually galaxies, because we actually saw things with a much more definition. And using spectroscope, he began to realize that the further away these galaxies were, the more red light they emitted, meaning that they were more red shifted, right? And so it winds up being that the universe is moving away from us, right? Two things. Firstly, the universe is expanding, and secondly, the universe had a beginning. And so if we have an expanding universe with a beginning, it leads the question for what began it. And Edwin Hubble, basically this became known as the Big Bang Theory, and this was actually a derogatory term used to describe, saying, oh, it was very much like a Christian type of worldview, that it is basically, well, everything started with a big bang, as the Bible suggested. And essentially it was a derision on Edwin Hubble as well. Thanks for watching. If you've got any questions, let me know. Have a great day, everyone. Bye.